Alright, today we're going to be learning about number patterns. So if you read this instruction at the beginning of class, you'll know that it just talks about how math we see everywhere, we see patterns everywhere, and we're going to talk about the number patterns that we'll be dealing with in class. So you were asked to look at the number pattern that we have on this first slide, and you see that as the numbers go to the expressions go to the next one, that first factor right there, the 12, becomes 123, and then 1,234. So we know that the next one in the sequence would go all the way to 5, from 1 to 5, and that would be the first factor. The 8 stays the same, but the number that we're adding at the end increases by 1. So this 12,345 times 8, we would add 5, and so on. So these kind of patterns we can tell just by looking and observing and being observant. Now, when we're asked to look at other patterns of numbers that we're going to be using kind of regularly in class, let's look at fractions like these 4 fractions here. You have 1/9, 2/9, 3/9, and 4/9. Now, if we were to open up a calculator, then we can see that they have decimal equivalents. So if we're going to change all these to decimals, let's see what they look like and if there are any patterns that we can recognize. So first, let's set up our notes that we'll be taking today. We're going to title this is lesson 115, and we're talking about number patterns. Okay, so in the book, if you are following along in the book, this is problem number 41, and then for reference you can check later if you need to. Our first fraction that we're going to look at is 1/9. And if you open up a calculator, you'll see, I'll save you the trouble. So if we open up a calculator, we can see that 1/9 just means 1 divided by 9. Because a fraction is just a division problem. 1 divided by 9 is equal to, and we see 0.111111. Now it doesn't end here, that's just how much room we have in our screen. This keeps going on forever and ever and ever. And it basically repeats, so we would say 1, 1, 1, 1, and then it goes on. So let's look at our next fraction, which is 2/9. And when you look at the division on a calculator, 2/9, 2 divided by 9, see this calculator even puts division as a fraction. You'll see that it is 0.22222222. So do we see a pattern yet? Do we see something that's going to happen that we can find out without using a calculator? Okay, so 3/9, we can assume, well, this is going to be 0.3333333333. Let's see. 3 divided by 9 equals, and that is true. So I think by looking at these patterns, we're now able to predict. Okay, so let's finish the rest. Let's do these. Let's do 4/9, 5/9, and then let's go all the way up to 9/9. Okay, so what you should see so far, or what you should have predicted so far, is that 4/9 is 0.444444, 5/9 is 0.55555, and then 9/9 does follow that pattern, but one thing you got to remember in math is that any number divided by itself is 1. So although we're looking at number patterns, we still have to be aware of mathematical principles. 3/9 can be reduced to a different fraction that is not a 9, because it looks here, we can see, well, that if we have numbers that have 9 in the denominator, we might be able to tell it's just a number that keeps repeating. Okay, but we know that this is 1/3, so 1/3 is also a repeating fraction. Okay, so on the next slide, it tells us that we could kind of look at the fractions that we worked with and write them in a different way. For example, 0.33333, we can write it as 0.3 with a bar over the 3. And this is something you might know from a previous class. So let's go ahead and change all of these fractions. Since we know that they repeat, let's rewrite them. Okay, so the first one we see is a repeating 1. So 0.1 with a bar over the 1 tells us that that's the digit that repeats. And let's go ahead and finish the rest. Okay, so here's what you should have so far. So all those repeating digits written in a shorter way. All right, so now let's talk about another kind of fractions and decimals, a terminating decimal. Now a terminating decimal is a number, a finite number, such as 2.173 or 0.04, because they don't repeat. We can see that the decimals kind of end right there at 4. This ends at 3. 1/2, 0.5, 3/4, 0.75. So let's kind of define that in a little more easier to understand way. This is problem number 42 in our book. So problem 42, we're going to first define terminating decimal. Terminating decimal. And just find out, well, why does that number, why is it finite? Why is 1/2 0.5 and why does it stop there? And the answer is, when we have a division problem or a fraction, which is a division problem, when we divide, we will eventually be done dividing. And how do we know we're done dividing? Okay, so let's take that example. Or let's take 3/4 as an example. So when we are done dividing, that means that division has ended. So once the division ends, we know we have a terminating decimal. So let's take, for example, 3/4. Okay, and let's divide. This is 3 divided by 4. So 3 divided by 4. Remember, the dividend goes inside, divisor goes outside. So we figure out how many 4s are in 3. This is the algorithm that we learned when we learned how to divide longhand. So there are 0 4s in 3, and then we put a decimal point. Now we can start looking at the decimal part of it. So 3.0, we can look at it as a 30, right? So 30 tenths. How many 4s are in 30? So that means we have 7 tenths. And then 7 times 4 is 28. We know that we were taught to subtract. And we have what was called a remainder when we first learned how to do that division process. But later on, we learned, well, we can still keep going here. Since we know decimals, we can bring down and go to the hundredths place. And now figure how many hundredths do we have. So 4 goes into 25 times. We have 5 hundredths. 4 times 5 is 20. And when we do that subtraction, we see that we don't have a remainder. So when we don't have a remainder, or we have a remainder of 0, that means our division has ended. And this tells us that we have a terminating decimal. All right, so terminating decimal means the division ends. There is a remainder of 0. Okay, so all these are kind of tied together. Okay, so let's see if this makes sense. We know that what a repeating decimal looks like, and now we know what a terminating decimal is. So this is problem 43 from the book. Let's look at some examples and tell me, is this terminating or repeating? So, our first one, we'll call it A, is 0.125. B is 0.6, and let's put that there. C is 5/6. D is 4. E is 2/5. And F is negative 0.33. Okay, so go to look through those and tell me which is terminating, which is repeating. All right. So, since we have a 5 with no decimals after it and no bar, we know that this terminates. Okay, for B, there's a bar over the 6. That tells us that we have a repeating digit. So this one is repeating. For number C, this is a fraction, so we don't know what it's going to look like as a decimal. So if anybody did take out a calculator, let's do this problem. 5/6 means 5 divided by 6. And is it terminating or repeating? We can see that there is a digit that repeats, and the 3's go on forever. Okay, so this is a repeating decimal. It doesn't have a 9 in it on the denominator, but we know that this is 0.83333333. Okay, so D, 4, that is a terminating decimal. 2/5. If you're familiar with your fifths, 1/5 is 0.2, 2/5 is 0.4. So that is terminating. And this also is a decimal, and it ends right there. So this is a terminating decimal. Okay, even though it's negative, even though there's 2 3's, it's still a terminating decimal. All right, so that was as far as the patterns that we'll go over. We're going to look at a different series of patterns in a portions web. Now, portions web is a graphic, kind of like a graphic organizer, and how we're going to organize our thoughts and organize the procedures in changing from a fraction to a decimal and a percent in all different directions, using words and pictures to show how all of these 3 things tie together because they mean the exact same thing. All right, so let's look at the example that we have here. So there it is again. It's in your toolkit. We have fraction, decimal, percent, words, pictures. That's what the graphic organizer looks like. And let's talk about how we would go about completing a portions web if any of these numbers were missing. Okay, so first, let's start with the fraction 3/5. Let's say we want to take 3/5 and change it to a decimal. Okay, so how do we change 3/5 to a decimal in that direction? And we know that that's a division problem. So if we take 3 divided by 5, we know that the answer is 0.6 or 6/10, right? So we can just divide. Now let's say we are taking the 0.6 and we want to change that decimal to a fraction. What do we do to change 0.6 to a fraction? And the key is you got to know place values. So when you're looking at your decimals, if you know the place value of that number right there, those are tenths. So that number is actually 6/10. And 6/10 reduces to 3/5. So that's what we would do to find that fraction. And now let's look over here to the fraction. If we want to write the fraction as a percent, what do we do? Right? So we know that 3/5 is 60%. Where does that number come from? So the way it came from is you need to know what percent is. A percent means percent. When we break it down, per means divided by. Right? If you go to the pizza place and with 5 of your friends and you get a pizza that's cut into 10 slices, how many per person? We would just divide that, right? And then cent means 100. How many years in a century? 100. How many feet does a centipede have? 100. How many cents in a dollar? 100. So cent means 100. So literally percent means divided by 100. So if we have 3/5 and we want to find out, well, what percent is that, we would just say 3/5 is what number divided by 100. All right, and then we can use different methods to find out. Well, there's 25s in 100 and 23s in make 60. We can do that way. Now, let's say we have 60% and we want to know, well, what is that as a fraction? We're going in that direction. Again, we think, well, that's percent. So 60% means 60 per cent. Per cent. And this reduces simply to 3/5. Okay, so that one's a lot easier. Now, here's one of the easiest ways to go from one to another when we're going from a decimal to a percent. How do we change 0.6 to 60%? And simply, we take that 0.6 and we move the decimal twice to the right. And then if we are going from 60% and we want to find out what is that as a decimal, well, 60%, there's the decimal right there, 60. We move it twice to the left, twice to the left, so that equals 0.6. Okay? Now, some of these can be circumvented. Like, let's say that this is difficult. I don't know proportions yet. I don't know how to solve proportional equations. So if I want to change 3/5 to 60%, I can go this way. Divide 3 divided by 5, that'll give you a decimal. And then move the decimal twice to the right. Okay, so save this. This is a very important little graphic that you can use. So let's talk about the next section here, which is portions web. Portions web. And here's how we'll be drawing them. So we are going to, this is number 44. For A, we're going to finish a portions web. Okay, there's those little connecting arrows that go there. We're going to start with four-fifths, and then we're going to make a portions web for 2/3. Okay, so what you should have gotten so far is 4/5 as a decimal is 8/10. 4/5 as a percent is 80%. And we can just say 4/5. Okay. Or if you wanted to draw it, we can draw this and just put here's 5 sections, and I just want to color in 4 of them. That's 4/5. Okay. Now we might want to make that a little bit more clear as far as how many sections there are. Okay, so there you go. So that's 4/5, or you can put words or drawings, remember. All right, so now let's do 2/3. 2/3 is a repeating decimal, and as a percent, it's 66.6 repeating percent. And as a, let's do a picture. Let's just draw 3 items, and we're going to color in 2 of those 3. So there's the 2/3.